Mael mixes 15 milliliters of bleach with 3.75 liters of water to make a sanitizing pollution for a daycare. The amounts of bleach and water always have to be proportional when he mixes sanitizing solution. Which of the following could be combinations of volumes of bleach and water for Mael's sanitizing solution? Okay, so before we look at the options, the answers, let's see the ratio between bleach and water. So Mael uses a combination of bleach and water, and the ratio is 15 milliliters per 3.75 liters. So if I divide the total amount of water, 3.75, by the number of milliliters of bleach, I get the ratio between bleach and water. So for every 3.75 liters of water, Mael uses 15 milliliters. Okay, so 3.75 divided by 15 is 0.0 times 15 is 0. Okay, 3 minus 0 is 3. Bring down 7, 15 goes into 37 twice. 2 times 15 is 15. Sorry, 2 times 15 is 30. And 7 remainder, bring down 5. 15 goes into 75. 4 times 15 is 60, and we have another one, so it's 5. Exactly 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. So no remainder, so 0.25. So Mael uses 0.25 milliliters of bleach. No. The concentration of bleach in the water is 0.25%, 15 milliliters. It's 0.25% of the total solution. Okay. So let's see if which options have the same ratio. 12 milliliters of bleach and 3 liters of water. 12 milliliters of bleach and 3 liters of water. 3 divided by 12. Three 12 goes into 32 times. 2 times 12 is 24. 6 left. Bring down to 0. 12 goes into 60 5 times. 5 times 10 is 50. 5 times 2 is 10. So it's 0.25. So option A is correct. 6 milliliters and 1.5 liters. So 6 and 1.5. And 1.5 divided by 6. 6 goes into 1. 0 times 0 times 6 is 0. Bring down 5. 6 goes into 15 twice. 2 times 6 is 12. Remember, bring down to 0. 6 goes into further 5 times. So it's also 0.25. So 6 and 1.5 liters is also correct. And 2.3 milliliters. And 0.75. Yes. Okay, so it means that if I multiply 15 times, so here to find the ratio, I divided 3.75 divided by 15. So for every 1 milliliter of bleach, I use 0.25 liters of water. So if I divide 0.75 by 3, yes, I get 0.25. Okay. So option C is also correct. So we need to find 3 answers. Let's see why these 2 last options are incorrect. Here I need to divide 5.5 divided by 20. 0 times 20 is 0. 5. Bring down 5. 20 goes into 55. 2 times 20 is 40. 15 left. Bring down 0. 20 goes into 150. 6 times 20 is 120. 38. 0. Okay, so I see 0.26 is incorrect. So option D is incorrect, and 3.75 divided by 11. And here we have 3.75 divided by 15. So option E cannot be correct. Okay. So I have my 3 correct answers. Good. Triangle A has a height of 2.5 centimeters and a base of 1.6 centimeters. So this is 2.5 and this is 1.6. The height and the base of the triangle are proportional to the height. The height and the base of triangle B are proportional to the height and the base of triangle A. Okay, so here we have a triangle. With a height of 2.75 and a base of 1.76. So to go from 2.5 to 2.75, 2.75 divided by 2.5 is 1.1. Okay, so to go from this height to this height, I need to multiply by 1.1 times 1.1. And to go from 1.6 to 1.76, 1.76 divided by 1.6 is also 1.1. Okay, so to go from 1.6 to 1.76, I multiply by 1.1. Okay, so option A is good. Let's see, to go from 2.5, which is the height here, to 9.25, 2.5 and 9.25. Okay, so the ratio here is 9.25 divided by 2.5, which is 3.7. This is the height and this is the base. And here we have a base of 1.6 and a height of, and a base 2.5 and 9.25, and the base is 9.16. 9.16. So the ratio is 9.16 divided by 1.6. So this is incorrect. Option B is incorrect because the base is not proportional. This base, 9.16, is not proportional to this base, 1.6. Okay, so option B cannot be triangle B. Option C. We have a height of 3.2 and the base of 5. Okay, and we see here that they are not increasing by the same scale factor. Okay, the height increases by 1.28 and the base increases by a scale factor of 3.1.25. If the base is 1.6 and this is of triangle A, and this is triangle B, so this cannot be triangle B. Option C is incorrect. Option D, height 1.25 and the base is 0.8. Okay, so this is also correct because here the scale factor of the height of triangle A is 2.5, height of triangle B is 1.25. So the scale factor is half. 0.5, 1/2. So to go from triangle A to triangle B, we shrink the height by half and also the base by half. So it's proportional. Triangle B is proportional to triangle A. The height and base of triangle B are proportional to the height and base of triangle A. Okay, so D is also correct. And here we have a height of 2 centimeters and the base of 1.28. Okay, and we see that when we divide 2 divided by 2.5 is 0.8 and here 1.28 divided by 1.6 is 0.8. So the scale factor is the same. So to go from a height of 2.5 to a height of 2, we need to divide 2 divided by 2.5 is 0.8. We need to multiply the height of triangle A by 0.8 to go to a height of 2. And we multiply the base by the same scale factor, which is 0.8. So it means the triangle B, the height and base of triangle B are proportional to the height and base of triangle B. So E is also good. So we have A, D, and E. A, D, and E. Sayge's spaceship traveled 588 kilometers in 60 seconds. Okay, so if it travels 588 kilometers in 60 seconds, seconds, so it travels 588 kilometers in 60 seconds. So its speed is 588 kilometers divided by the time, which is 60 seconds. So it's 9.8 kilometers per second. Okay, so this is Cygnus spaceship. Okay. Determine whether or not each spaceship trip below has the same speed as Cygnus spaceship. So this spaceship travels at a speed of 441 kilometers in 45 seconds. Okay, so option A travels 441 kilometers in 45 seconds. So the speed is the number of kilometers divided by the number of seconds. So the speed of option A is the same as Cygnus spaceship. So option A is good. Option B, here the spaceship travels 215 kilometers in 25 seconds. So I divide 215 divided by 25. It's not the same speed, so this option is not good. Option B does not have the same speed. Option C, we have 649 kilometers, and we have 110 seconds. So I can copy the formula from here to here without paint. Okay, so here again we divide cell C5, C5 divided by D5. C5, this is D5. Okay, so 649 divided by 110 gives us 5.9, which is not the same speed as Cygnus spaceship. So option C is incorrect. Option C does not have the same speed. Okay. The table shows a proportional relationship between the milliliters of red paint and milliliters of yellow paint to make a certain shade of orange. Okay, so I have red paint and yellow paint, and the ratio between red and yellow. So I have 10.5 and we have 28 milliliters. So for every 1 red milliliters, and also the yellow milliliters. So for every, if I divide the 28 milliliters of yellow by 10.5, so for every 1 red milliliters of paint, I need 2.666 repeating milliliters of yellow. So this is the ratio in the table. Let's see that this ratio is also kept for the next options: 20 milliliters of yellow and 7.5 milliliters of red. 20 divided by 7.5, same ratio, okay, and 24 and 9. Can copy the formula, so it's the same ratio. 2.666 repeating, 2 2/3. There are 2 2/3 more milliliters of yellow paint in the mixture than milliliters of red paint. Okay, now I need to find two answers where the ratio is the same between the red and yellow paint. So option A has 1.25 milliliters of red and 5 milliliters of yellow. Here the ratio is 4:1. Okay, so for every 1 red milliliters I need to multiply times 4 to get to the amount of yellow milliliters of paint. So option A is incorrect. Option B, 1.5 milliliters of red and 4 milliliters of yellow, 2.66. Okay, so 2.66 is when I divide E8, which is this cell, divided by D8, which is this cell. So 4 divided by 1.4 is also 2 2/3. So option B is good. Option C, 8 milliliters of red and 3 milliliters of yellow. So this is not logical because we have here more red than yellow. So 8 and 3. And obviously when I divide 3 divided by 8, I will not get the same. Here there is more red than yellow. And here there is more yellow than red, so obviously option C is incorrect. Option D has 7 milliliters of red and 16 milliliters of yellow. Here the ratio is 16 divided by 7, which is 2.28, so it's not the same. So we are left with option E. Option E, 4.5 milliliters of red and 12 milliliters of yellow. When I divide 12 divided by 4.5, same ratio. Okay, so options B and E are correct. B and E. Okay, at East Middle School there are 58 left-handed students. Okay, so left-handed and right-handed. And ratio is 58 left-handed and 609 right-handed. Okay, so we have left-handed, right-handed, 58 and 609. So the ratio, I divide the total numbers of right-handed by 58, which is the number of left-handed students. So for every one left-handed student, you need to multiply by 10.5 to know how many right-handed students there are. Okay, numbers of left and right-handed students at West Junior High are proportional to the numbers at East Middle School. Okay, so West Junior High has the same ratio between left-handed students and right-handed students. So which of the following could be numbers of left-handed and right-handed students at West Junior High? Okay, so option A, there are 42 left-handed students and 483 right-handed students. Okay, so when we divide 483 divided by 42, we get 11.5. Okay, I copied the formula from this cell to this cell, so I see that option A has not the same, it's not the same ratio, so it's not good. Okay, so let me copy, color it in red. Option B, there are 28 left-handed students and 378 right-handed students. So here the ratio is 13.5, which is not the same ratio. Option C, we have 48 left-handed and 504 right-handed. And I copy the formula, so the same ratio here. So here I divide F12, which is this cell, F12, F12, 504 divided by 48, divided by E12, which is this cell. So it gives me 10.5. So option C, the same ratio as the original ratio. So this is good. Option D, we have 56 and 560, which is 10. Okay, 460 divided by 56 is 10, so it's not the same ratio. So option D is incorrect. Option E should be correct because we need to find two answers. So this is 30, this is 315. And when I copy the formula, I get the same ratio. So here I divide F14, which is this cell, 315. I divide it by E14, which is this cell, E14. So 315 divided by 30 gives me the same ratio of left-handed to right-handed students. Okay, so option C and E. Okay, so here I have Mumbai. Mumbai is approximately 845 kilometers away from Bangalore. And here I have Bangalore. And this segment here is 845 kilometers. Okay, and Mumbai is approximately 1,160 kilometers away from Delhi. So let's say Delhi is somewhere down here. This should be longer. So this is Delhi. Okay, so this is Delhi, and this segment here is 1,160 kilometers. The distances measured in centimeters between the cities on Allison's map are proportional to the real distances. Okay, which of the following could be the distances on Alison's map? Okay. So we have Mumbai to Bangalore, distance is 845 kilometers. And Mumbai to Delhi, the distance is 1160. Okay. Option A the distances measured in centimeters between the cities on Alison's map are proportional. So on Alison's map, we have here option A, Bangalore to Mumbai 116.5 and 174 from Mumbai to Delhi. So this to this needs to have the same ratio. So 845 needs to relate to 116.5 the same way as 1160 relates to 134. So we need to find the relationship between 845 and 116.5 and see the same relationship here between 1160 and 174. So the relationship between option A, we have 116.5 and 174. So the ratio here, scale factor. I divide 845 divided by 116.5. So I need to multiply for every 1 centimeter. Every 1 centimeter represents 7.25 something kilometers on the map. And here, when I divide the number of kilometers by the number of centimeters, every 1 centimeter represents 6.6 kilometers. So it's not proportional. So option A is not good. Okay. Option B. Option B, we have Bangalore to Mumbai 42.25 centimeters and Mumbai to Delhi 58 centimeters. Okay, so here we have the same ratio. It means that every F7 divided by FG7 means that you see here the formula F7 is 8.4 divided by G7. When I divide 845 kilometers by 42.25, it means that every 1 centimeter on the map represents 20 kilometers in real life. Okay, and here the ratio is the same. So option B is correct. So option B is good. Okay, option C. Bangalore to Mumbai 23.4 and 29 centimeters. Okay, so not the same ratio. Here when I divide 8 F7 and G7, when I divide 845 by 23.4, it means that every 1 centimeter represents 36.1 kilometers on the map, and here it represents 40 kilometers. Every 1 centimeter represents 40 kilometers on the map, so option C is incorrect. Option D, we have 16.9 kilometers from Bangalore to Mumbai and 23.2. Okay, so here the same ratio, so option D is good. So when I divide the distance in kilometers by the number of centimeters on the map, I get 50, so it means that to go from the map to the real life, I need to multiply each centimeter by 50, and then it represents the number of kilometers in real life. Okay, and here the same. So when I divide 1,160 kilometers by 23.2, I get 50, which means that every 1 centimeter on the map represents 50 kilometers in real life. So the ratio is the same, so option D can be good. So we need to find 3 answers, so option E must also be correct. So here option E Bangalore to Mumbai 25.35 and 34.8. Okay, so here we get the same ratio, so this option is also good. When I divide 845, which is F7, divided by G7, which is 25.35, I get 33 1/3. So every 1 centimeter on the map represents 33.33 kilometers in real life. Okay. Okay, so the same ratio, which means option D is also good. So B, D, and E. Jack popped some popcorn, but 3 of the 150 kernels did not pop. Determine whether or not each popcorn snack below has the same ratio of unpopped to total kernels as Jack's popcorn. So 3 did not pop. 3 total number of kernels are 150. So to go from 3 to 1, we divide by 3. To go from 100 to, we need to divide by the same number. So 1 out of 50 did not pop. Here, when I divide 75 by 2, 75 by 2, 70 divided by 2 is 35, and 5 divided by 2 is 2.5, so it's 37.5. So here the ratio is 1 to 37.5. for each one unpopped kernel. There are 37.5 kernels. Out of the total number of kernels, one of 37.5 did not pop. So this is not the same ratio. Here, 1 of 50, yeah, 200, 4 to 200, 4 to 1, I divide by 4, I get 1, divide by 4, I get 50, so 1 to 50. So this is the same ratio of unpopped. And 1 out of 50 kernels, the same ratio. Okay, so option B and C are correct. One out of 50. 1 out of 50 did not pop. This is not the same ratio. Okay. Good. Thank you for watching. And in the next video, I will move on to what? To this section, graphs of proportional relationships, and I will do this practice, identify proportional relationships from graphs. So I will see you in the next video.